Okay, here's the solution to the problem at the end of Wednesday's video. So that was the video, the proof part 2 video. We had to say that for any natural number, so natural numbers are just positive counting numbers, 1, 2, 3, 4, 5, 6, 7, 8. We had to prove that n cubed plus 2 is not a multiple of 8. And it's quite good because it throws up a couple of ways of demonstrating that. And this is a proof by exhaustion question because we get different scenarios with even and odd. So for even numbers, I've replaced n with 2x. I thought 2n would be a bit too confusing, so I'm using x instead. So I've rewritten this, replacing n with 2x, just because it's an even number. 2x cubed, 2x times 2x times 2x is 8x cubed, plus 2. Now, this I know is divisible by 8. Anything that's 8 times something is going to be a multiple of 8. If you add 2 to a number that's a multiple of 8, you don't get another multiple of 8. So therefore, when n is even, it's not divisible by 8. What about when n is odd? So I've replaced n with 2x plus 1. So I do 2x plus 1 cubed plus 2. So to do 2x plus 1 cubed, I had to do 2x plus 1 squared, take my answer, multiply it by 2x plus 1 again. Gave me this. And this time, I can't show this is equal to 8 times something, but I can show that this is equal to 2 times something. So it's even. Now, all multiples of 8 are even. If you add 1 to an even number, you get an odd number. There are no odd multiples of 8, so I know that that is not divisible by 8. So I'm then going to just write a little summary thing. So what I've done is I've shown that this is not divisible by 8. So therefore, n cubed plus 2 is not divisible by 8 as required. Okay, go. So we are going to stop proof there temporarily. We haven't finished proof. We'll carry it on in the new year. So instead, what I'm going to do today, and what I've attached to the email today, is a copy of a practice paper and a mark scheme. Now, this is not homework. I've set you homework that's due on Friday, and I'm not setting you Christmas homework. But I think now is a good time for you to have a look at a practice paper. It's not a genuine past paper. We haven't got many of those because it's only run for a few years. So this is a practice paper produced by a third-party website, but it's pretty good, and it gives you a look at the format of the Edexcel exam papers with the questions and then lots and lots of lined pages for you to do space. Please don't print it. I really recommend you don't print it. I reckon that you should be able to do those questions with the content that we've done so far. And it's that's a fair chunk of the paper, probably just slightly over half the paper. Don't be afraid, don't be scared by the questions that I'm saying you can't do. They might look a bit scary, but we'll be fine. By the end of the year, we would have covered it all easily. I just want to highlight a couple of the questions now and sort of help you on your way. I know you've got the mark scheme, but mark schemes sometimes I find are not particularly helpful at explaining how something has been done. So I'd just like to go through a couple of the questions now. So firstly, question 4. Question 4 is a straight line equation. It's a question about perpendicular lines. We've done lots of this, but it's nasty in that they talk about one line and they give you the equation of that straight line in a really rather odd form. Okay, it's in the ax plus by equals something form, but it's got k's all over the place. We're asked to find the gradient, so I've rearranged it into y equals mx plus c form. So I took away kx from both sides and then divided everything by 1 minus k. And that gave me this statement here. And it asks for the gradient. Well, the gradient is the number of x's, so I can see from my statement that the gradient is minus k over 1 minus k. It's the number of x's, the coefficient of x. I know in the mark scheme they put the minus sign out in front. It means the same thing. Here you've got to work out the gradient of a line joining 2 points, which we can do. We've got a missing value, so you might find you're better off using the formula. y2 minus y1 over x2 minus x1. And then you've got to show that they're perpendicular. Now, we're all used to my little way of remembering how to do this, but there was another way, wasn't there? If two gradients are perpendicular, then their product is equal to -1. If you multiply them together, you get -1. So, for example, we know that -2 and a half are perpendicular gradients. So they multiply together to give you -1. Now, I've given you one gradient. It's that. So minus k over 1 minus k. And hopefully you'll work out a gradient for this one by just working out the gradient of the line joining those 2 points. So you'll get another gradient here, also involving k. And we know that they're equal to -1. So what you've got to do here is turn that equation into this equation and then solve it. I think that's probably the hardest question on the paper, but hopefully I've given you a bit of a nudge. See how you get on. Question 8a is a proof question, and they put it in funny words. You've got to prove that this is always positive. So what you've got to do is prove that this is always greater than 0. And in Wednesday's video, I solved a similar problem by completing the square and showing that it never crossed the x-axis, so therefore it was always positive. There's a couple of other ways you could do that. I haven't looked at the mark scheme, actually, to be honest. I don't know how the mark scheme does it. And 8b, well, I mean, by all means have a look at that. We haven't finished proof, but you might want to see if you can get somewhere with 8b as well. And question 9 looks scary. It's a fiddly question. It is a fiddly question. Let me just give you a couple of little hints. Firstly, can I remind you that if you've got something like a cubed to the power of 4, that's the same as a to the power of 12. You multiply the powers. So this to the power of, to a square rooted, I could write that as 2 to the power of x plus y to the power of a half, which you could simplify in a similar way to that rule there. And over here, I've got 1 over 8 to the power of y plus 1, so that's 8 to the power of y plus 1 to the power of -1. That means the same, doesn't it? 1 over the power of -1. So you could simplify that in a similar way to that one. I also note that 2 to the power of 3 is 8, so I could replace the 8 with 2 to the power of 3. And then everything would be in terms of powers of 2. And if you have an expression that says 2 to the power of something equals 2 to the power of something, then those two somethings have got to be the same. With this one here, rationalise the denominators. So on this side, you're going to do that by multiplying top and bottom by root 3 plus 1. And here you're going to do it by multiplying the top and the bottom by root 3. And that's going to give you something which hopefully you can simplify and sort out. I mean, that's a 7-mark question. We're expecting that to be hard. So I'm not showing you this practice paper to scare you. Just want you to get your head around A, what the exam papers look like, and maybe feel that you've made some progress this term, and you are able to make some progress. Remember, 30% is the magic number to get a grade, and then 40, 50, 60, 70 to get grades above that. So you can maybe make some sort of judgment as to where you stand at this point. It's been great fun working with you this term, and I do hope you have, amongst a little bit of independent study, you have a good break. Remember, this isn't homework. I'm not expecting this to be handed in. I'm not going to mark it. It's just for your benefit, really, to give you a chance to reflect on the progress you've made. I will be checking emails if you have any questions you want to ask, and I hope that we are able to get together again in January and carry on learning together. Take care.